The topic for Lesson 13.4 is measures of variation. You'll learn how to find the range of a set of data, find the quartiles and interquartile range of a set of data. How is variation used in weather? The average monthly temperatures for 3 U.S. cities are given. Which city shows the greatest change in its monthly highs? To answer this question, find the difference between the greatest and least values in each data set. So for Buffalo, the difference was 80.2 to 30.2 is 50 degrees. Honolulu is only 8.6, and Tampa is 20.4. So Buffalo obviously shows the greatest change. The difference between the greatest and the least monthly high temperatures is called the range of the temperatures. The range of a set of data is the difference between the greatest and least values of the set. I love finding typos. College, not collage football. The teams with the top 15 offensive yard gains for the 2000 season are listed in the table. Find the range in the data. So range, we said, is the largest, which in this case would be 6,588 minus the least, looks like 4,000. Oh, nice. 789, which happened to be right next to it. And the least minus the greatest is 1,799 yards. Now, range is the most basic spread of data. Next, we want to look at quartiles. In previous courses, we've talked about the mean, which is old average, add them together, divide by however many you have. Median is the middle of the list, and mode, most often, to describe the central tendency of a set of data. The range of the set of data is a measure of spread of data as well. Measures that describe the spread of the values in a set of data are called measures of variation. Now, the root word of quartile is quart, which we know means it's breaking something into fourths. In a set of data, the quartiles are values that separate the data into 4 equal subsets, each containing 1/4 of the data. Statisticians often use Q sub 1, Q sub 2, Q sub 3 to represent the 3 quartiles. Remember that the median separates the data into 2 equal parts. Q2 is the median, which is usually referred to as median. Q1 is the lower quartile. It divides the lower half of the data into 2 equal parts. Likewise, Q3 is the upper quartile. It divides the upper half of the data into 2 equal parts. The difference between the upper quartile and the lower quartile is the interquartile range. The difference between the upper quartile and lower quartile of a set of data is called the interquartile range. It represents the middle half, or 50% of the data in the set. The areas of the 5 largest states are listed in the table. Find the median, lower quartile, the upper quartile, and interquartile range of the areas. Now, normally we'd want to deal with all 50 states, but they're making the problem simpler for us. So we just need to list these 5 in order from least to greatest to find the median. And conveniently, because we have an odd number, the median is going to be 164. It is the middle of the group. Now, it's not so convenient finding our quartiles. So our quartiles are going to be halfway between and halfway between. So just like when we had to do the median of even number of data, we had to divide our 2 most middle by 2. We're going to do the same thing for our quartiles. We're going to add them and divide by 2, so we're finding the average. So the average between 124 and 147 is 135 and a half. And the average between 269 and 656 is 462 and a half. So to find the interquartile range, we just need to get the difference of Q3 and Q1. So 462 and a half minus 135 and a half. And the difference is 327. And the units were all in 1,000 square miles. Not a real convenient label there, was it? So that was Q1, Q3, there's our median, and there's our label. We got it all. In a set of data, a value that is much less or much greater than the rest of the data is called an outlier. An outlier is defined as an element of a set of data that is at least 1.5 interquartile ranges less than the lower quartile or greater than the upper quartile. When the person that came up with this concept was asked why 1.5, he said because 1 was not enough and 2 was too much. They were ever so kind in example 3 when they asked us to identify outliers because they gave it our data in a stem and leaf plot. So that means, of course, it's organized for us in order from least to greatest. And here's our key, 4 bar 7 equals 47. And they even have counted for us. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pieces of data. So they were so kind as to count 10 and 10, and there's our median. But what we're really interested in is Q1 and Q3. So I need 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So our Q1 is going to be halfway between 72 and 72. And yes, it looks like Q3 is going to be just as difficult to find, sarcasm much. It's going to be halfway between 87 and 87, which gives us an interquartile range of 87 minus 72, which is 15. Okay, so now we're going to look for outliers. If I take my Q1, which is 72, minus 1.5 times 15, I get my breaking point for outliers there, which is 49.5. And on the other end, if I take 87 plus 1.5 times 15, I get my top end extreme of 109.5. Now, looking back at our list, we don't have any values greater than 109.5, but I do have one number less than 49.5. So 47 is an outlier. I think that's a fairly new concept, so let's look at another one like that. This time we have 18 pieces of data, and so we want to break it up into 9 and 9. Which is convenient because now to find my Q1, it's going to be the 5th piece of data, which leaves a nice 4 on either side of the 1. And on the other end, I need 1, 2, 3, 4, 5, and that leaves 4 above it also. So my Q1 is 41, and my Q3 was 55. So to get my interquartile range, I need to subtract 55 minus 41, and I get 14. Doing the arithmetic on the bottom end, I get 28, and on the top end, I get 76. I do not have anything less than 28, but 79 is greater than 76, so 79 is an outlier. Now, sometimes they were kind of stinkers and gave us a bunch of problems that did not have outliers, so just because you check doesn't mean you will find what you seek. The range of the data set is the difference between the greatest and least values of the set and describes the spread of the data. The interquartile range is the difference between the upper and lower quartiles of the set of data. It is the range of the middle half, or 50% of the data. Outliers are values that are much less or much greater than the rest of the data. By much, we mean 1.5 times the interquartile range.